Welcome to this video on Python closures. In this video, we are going to understand closures and inner functions in Python. So, what exactly is a closure? A closure is a function object that remembers values in the enclosing scope, even if they are not present in memory. Consider these key characteristics. A closure has a function inside another function which is called as a nested function. The inner function has access to outer function variables, and the outer function returns the inner function. Let us understand this with a code. Here is a simple example in Python. We define an outer function that takes a parameter x. Inside, we define an inner function that takes a parameter y. The inner function returns the sum of x and y, where x is from the outer scope. Finally, the outer function returns the inner function. Let's delve into a basic closure example. We define a function called multiply by, which takes an argument n. Inside multiply by, we define another function called multiplier which takes an argument x. The multiplier function returns x multiplied by n. Finally, the multiply by function returns the multiplier function. Now let's create closure functions. Double is equal to multiply by 2. And triple is equal to multiply by 3. Now we can use the closure functions. Print double of 5 which results in 10. Print triple of 5 which results in 15. The variables double and triple are closures. Each remembers its own value of n from when it was created, even after the original multiply by calls have completed. Let's understand how closures work. Step 1: Function creation. When an inner function is defined, Python captures the enclosing scope variables. Step 2: Lexical scoping. Closures use lexical scoping, meaning they can access variables from the containing function. Step 3: Function return. The inner function is returned, with its environment including captured variables intact. Step 4: Persistence. The captured variables persist even after the outer function completes execution. Let's look at the free variables in closures. Here is an example. Define a function counter. Count equals 0. This is a free variable. Define a function increment. The nonlocal count is required for modification. Count plus equals 1. Return count. Finally, return increment. In Python, you can check the free variables that a closure is referencing using the _closure attribute. The keyword nonlocal is required to modify variables from the outer scope inside the inner function. Let's look at a practical example of data validator. Define a function create validator, which takes two parameters, min value and max value. Create a custom validator function. Define a function validate which takes a parameter value. If the value is less than the min value, then return a string saying value and the value is too small. Else if value is greater than the max value, then return a string saying value and the value is too large. Else return a string saying value and the value is valid. Finally, return validate. Now we can create specific validators. Temp validator equals create validator 0 to 100. Age validator equals create validator 0 to 120. Now we can use the validators. Print temp validator 25. The output is valid. Print temp validator 150. The output is too large. This example shows how closures can create specialized functions with pre-configured settings. Each validator remembers its own min and max values, creating reusable validation functions for different data types. Here are the benefits of this approach. Encapsulation of configuration data. Factory for specialized functions. Cleaner code by avoiding global variables and reusable validation logic. Now let's see how to modify enclosed variables. Define a function counter function. Count equals 0. Define a function increment. Nonlocal count is required for modification. Count plus equals 1. Return count. Finally, return increment. Counter equals counter function. Now let's use the counter. Print counter which results in 1. Print counter which results in 2. Print counter which results in 3. In Python, variables that are only referenced inside a nested function are implicitly available. However, to modify a variable from the enclosing scope, you must declare it as nonlocal inside the inner function. Without the nonlocal keyword, Python would create a new local variable instead of modifying the enclosed one. The nonlocal keyword was introduced in Python 3. In Python 2, you would need to use mutable objects like lists or dictionaries as a workaround. Here are some common use cases for closures. Number 1. Data hiding or encapsulation. Closures provide a way to hide data from the global scope, similar to private variables in object-oriented programming. Here's an example. Define a function create account which takes a parameter initial balance. Balance equals initial balance. Define a function get balance. Return balance. Finally, return get balance. Number 2. Function factories. Create specialized functions with pre-configured settings for different scenarios. Define a function power function which takes a parameter exponent. Define a function power which takes a parameter base. Return base to the power of exponent. Return power. Square equals power function 2. Cube equals power function 3. Number 3. Callback functions. Closures can store state that persists between callback invocations. Define a function create counter callback. Count equals 0. Define a function callback. Nonlocal count. Count plus equals 1. Print called count times. Return callback. Number 4. Decorators. Python decorators are implemented using closures to wrap and enhance functions. Define a function timer decorator. Define a function wrapper which takes arguments and keyword arguments. Some code before function call. Result equals function with arguments and keyword arguments. Some code after function call. Return result. Return wrapper. Here are some best practices in summary for closures. Best practices. Keep closure functions small and focused on a single purpose. Use nonlocal only when necessary to modify enclosed variables. Avoid excessive nesting of functions which can lead to confusing code. Use descriptive names for both outer and inner functions. Document the intended behavior and relationship between the functions. Consider using classes for more complex cases with multiple methods. Summary. Closures are functions that remember their enclosing scope. They consist of an outer function containing an inner function. The inner function can access variables from the outer function's scope. The outer function returns the inner function. Use nonlocal keyword to modify enclosed variables. Closures are powerful for data hiding, function factories, callbacks, and decorators. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.